Before I go do your homework, we're going to go over floating point a lot next class, and it can be very confusing. So I want to at least do a mild introduction right now, and then I'm going to introduce it again next class. But this is just to make sure that everyone gets it in their brain what's going on.
Okay, we shall allow that.
Oh, well, thank you so much. All right. So quick, this isn't hard, just pay attention for now. Floating points for scientific calculations. A lot of times you're doing simulations. You want to maybe watch the points inside of space, and you're doing, like, I don't know, asteroids hitting Saturn, and you want to simulate it or something. So they're going to use scientific notation. Floating point's a way to represent scientific notation. Notice that scientific notation doesn't limit itself just to integers. You can also do decimal formats as well. So with scientific notation, if you recall, your first bit was on, or first bit was not 0, it was 1 to 9, followed by whatever decimal times 10 raised to whatever power. Everyone remember that scientific notation? All right, great. In binary, you're going to do the same thing, except for instead of leading with 0, it has to lead with a 1 dot some fraction, base 2, and then you multiply it by 2 raised to some power. Because, hey, look, it's a computer. It doesn't do base 10. Okay? Keep in mind also that these two are not normalized. Why are they not normalized?
Because they still have like in order for it to be normalized, it need to be like 2 or like 9 point something.
Right. So to be normalized in base 10, that first digit has to be 1 through 9, 1 through 9, and it must not have anything in front of it. Okay? Everyone got that?
Yeah.
Got that? So in binary, what does that digit have to be? A 1. So we can actually, we'll get to this in a moment, but the 1 right there is always implied, and you actually only store what's after the decimal, because the 1 has to be there. So you have different types of floats, or floating point. You have float and double in C. All right, this has been standardized. That's great. So here's the excuse me, the way it is stored. Your first bit is the sign. Is it -1? Is it negative or positive? Next comes the exponent, which dictates what 2 raised to whatever is.
Whatever.
And then your fraction is, of course, 1 plus the fraction, because like I said, that initial 1 is implied. And this fraction, what actually is happening with the fraction is that you're storing half, fourth, eighth, 16th, dot, dot, dot. All right, what am I talking about? You know how in binary, it was the first bit was 1, then 2, then 4, then 8. This is in reverse, because you're doing the notation afterwards. So it's 1 plus, you either turn on a half, a fourth, an eighth, a 16th, dot, 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 depending on how many bits you have. Y'all see what I'm doing here? So this number has to be between 1 and just under 2. It has to be between those two values. All right, here's the question to make sure you all see it. Can this represent any number?
Should.
Oh, how will it represent 0? Oh, no, never mind.
Oh, skip 0 for now. We'll skip 0 for now, just for now, because that was a good point. We'll get to that later. Okay, so you can represent a half, basically by changing the exponent to be 2 to the -1. So that's how you can do a half. Yes. Bless you. But notice that the exponent, bless you again, it's okay. It's just shifting the magnitude, right? That's the order of magnitude. The fraction part is shifting or giving you your resolution into the number. So ignore the 1 now. Can this represent all numbers between 0 and 1? Just this fractional bit. A third, that was great. How would you represent a third? You can't. Everyone got that? Floating point and doubles cannot represent a third 100% accurately. That's why a lot of times when you do a calculation of 1/3, you get something that's not quite 1/3. All right. And I'm going to stop there. Because if you got at least that much in your head, next class will make a lot more sense. How are we doing back here? I never asked. You doing all right? Okay. All right.